Thank you very much for great talk. And yes, you cover everything, and yes, I have also attacked many of these questions with a bit different maybe answers. So maybe let's go to the discussion. So everybody is welcome to unmute and comment, ask.
You mentioned that photons rotate twice per wavelength in the beginning. Why do you have this idea?
Well, it's that is the foundation of the model. As I mentioned, I use only known physical principles. Although the physical principle of E equals mc squared was known since 1905. The physical principle of the interchange between particles and photons has been known for about 60 years. It just so the way I worked it out was to start out with that model and solve from I omega is half h bar to E equals mc squared. I could have gone the other way around, started with E equals mc squared, which was physically known, and worked back the other way and get I omega equals half h bar. But the two revolutions is because they're the only combination where the magnetic fields overlap and the electric fields are on the same side, on the same quadrant. So no other combination does that.
What is the structure of a photon? It's a point, or it's a massive point, or what is your picture from it?
The mass of the photon is just it's h nu, Planck's constant times its frequency.
So it's an integral over energy density, or what is it? Is it a field?
It depends on the units of that you use, but it's defined as electron volt. Well, it can be defined as any mass unit. It's usually in this situation defined as MEC per c squared, but it can be its mass can be defined in kilograms, in grams, whatever dimension you want. It is its dimension. H nu is a mass dimension. So questions again.
Okay, so one issue I have is that there are some nuclei with additional neutrons. There are halo nuclei, like helium 6, helium 11, helium 8, lithium 11, and they have 2 neutrons usually for a very long time, like a few milliseconds. Could you have this binding of for a very long time of neutrons in distance, a few femtometer distance?
Yeah, the neutrons, of course, you can get magnetic binding when the neutrons have the same spin and are close to each other. They can get magnetic binding. There will be some repulsion, but if they're not quite in the same plane, that you'll still get the magnetic binding, but you won't get as much charge repulsion.
So I don't think the magnetic binding is sufficient. You have two neutrons for milliseconds in distance of like 5 femtometers from the nucleus. You have 2 neutrons, and they are binded for milliseconds. So it is much farther than nuclear force class standard view.
What sort of distances when you say they combine for 5 seconds? What sort of distances are you talking about?
Like 5 femtometers from nucleus. There are two neutrons binded for a few milliseconds.
Oh, I mentioned, or I showed earlier, that 2 electrons could be magnetically bound to each other. There's no reason why 2 neutrons on the same spin can't be magnetically bound to each other as well.
Electron, I think you are talking about Cooper pairs. This is in a lattice, and there are very large distances. But here I think it's a bit different mechanism. But maybe similar.
Yeah. Like the same thing, you can get, as I showed with that electron entanglement, there is no reason why that can't occur also with protons, neutrons. It has to be set up correctly, and it could last for a little while, but I don't know the exact conditions, but this model doesn't exclude it as far as I'm concerned.
Okay, so for Coulomb interaction, I think what you have shown is that there you need some direction. So it should depend. Does it depend on the spherical angle from the Coulomb interaction in your picture?
No, the Coulombic interaction I was talking about is where they're in the same plane and the charges overlap. And that very short overlap. I mean, if you take the standard model where charge is distributed throughout the whole molecule, the chances of binding, electromagnetic binding, are just or electric binding are just non-existent. But when they are generated in the same plane and overlap, then you've got this division by zero situation, and very small charges overlapping directly can give rise to quite strong forces.
Okay, so for two electrons, indeed, there are these problems with very low distances, and so they are observed, for example, in the running coupling effect, that you have deformation of Coulomb interaction for very low distances, and it should be recreated in the model. But for long distances, do you have this? I think I have seen an image with some two planes for electrons. So it suggested that you have dependence on the spherical angle, while in nature you don't have such dependence.
No, I didn't quite understand, but this curving electrons won't occur. All motions will be basically straight line until photons are exchanged.
I think he meant that charge is, spherical is symmetrical, right?
Yes,
and it looked like in your
Coulomb
model
is
it was
spherical.
not exactly. Is that what you meant, Jarek?
I thought I have seen some slides, some like at the beginning that which suggested that Coulomb interaction in your model is not spherically symmetric.
Certainly, the standard model treats charge as symmetric in 3 dimensions. I'm suggesting charge is symmetric, but only in 2 dimensions. Yeah. And the experimental measurement of the charge distribution for protons and neutrons gives a very, very strong indication that is the case, because particularly the central point of that curve is 0. And the only way you get a 0 central with something charged is if the charge is either cylindrical or planar. You won't get a 0 center if charge is distributed uniformly.
May I ask another question? Is your model a particle model or a field model? And what is your Hamiltonian?
I describe it as a particle model. I describe it as a particle model. The particle is the photon, but the photon is a field. A photon has electric and magnetic fields, and that's all a photon is. It's just electric and magnetic fields. So we start out with a field, which is the proton. We get it, the photon, when it rotates twice, it generates the particle. From then on, that particle generates all the fields. And as I suggested there, they've even got gravity thrown in as well. They're generated by the particles. But the particles themselves are generated by fields, the fields being the photons.
Do you have a Hamiltonian, an energy expression? Like in quantum mechanics, you have Hamiltonian and wave function. Do you do some calculations on this model?
I've done a lot of calculations. They're in that book to which I made reference to, and I will be posting more. I've got some of it is already posted up on the Quicycle website, and I will be posting more there later. Most of the calculations are done, but as I pointed out at the beginning with Einstein's relativity theory and the way the mathematicians have used it, they've just made, I agree that his mathematics was complex, but there's no excuse for not reading it and understanding it correctly. And I just would like to suggest that if you use mathematics only without a physical support, without a physical reason, you are likely to run into that situation. And I know the cosmologists, the theoreticians will say black holes have been proven, everything else is proven, but Einstein didn't believe in them. The only way Mercury's orbit can precess is if gravity is weaker than inverse square. And if the sun's gravity is weaker than inverse square, then the gravity of every other star is also weaker than inverse square. So the gravity in space is actually weaker than inverse square. And that has significant consequences for cosmology. And what I'm trying to say is that if you just use, like the theoreticians who believe they understood Einstein's field equations and expanded on them, and he points out many times that his work was approximation, no matter how good or accurate your work is, if you're starting out with approximations, you're going to finish up with approximations, and to try and get some magic meaning out of approximations is not the right way to go. And that's why I suggest, look, go the physics first principle. And Einstein actually, in his 1911 paper, calculated the physics that he used. I think he went to field equations because Einstein, not long before him, had published some work on trying to relate electromagnetic fields to gravity. And I think he was just repeating, or believed he could repeat that same sort of mathematics. But please, I've used the physics first, and then the simple math. The math, in my situation, I think the maths is much simpler than what other people are using. I've justified everything. I believe I've justified everything that I've used. And I'm not, I think people should be very careful about using mathematics. You've only got to get one little thing wrong. And in the case of Einstein's work, yes, he did mention terms with the minus sign more often than he did the terms with a plus sign, but he also stated at the beginning with that minus sign that they were approximations. And to suggest that exact solutions to approximations are exact solutions is, they're only ever approximations. And that's why I'm in favor of describing the physics first and then using the mathematics necessary to support it. And that's what I believe I've done in this case. And I think, well, I hope some of you found it useful. And for any nuclear physicists out there, I think you'll go much better using this model than trying to continue the way theoreticians are going at the moment.
I thought it was really interesting, and I also see some similarities between your model and the model from Robert Close. Unfortunately, he had to leave, but I was wondering, have you read his work as well? Or maybe I can send you a link.
I saw some
similarities.
I've read some of his work, not all of it, I'm afraid.
And so I was wondering, do you have any thoughts on what that field is, space? Is this, in Robert Close model, it's an elastic solid. Do you have any thoughts on that? What that field is, that everything is based on?
Space is empty space. It's got nothing in it. Well, that's not quite true. The one thing that space has everywhere is cosmological neutrinos. So you can never have this pure thing called empty space. The actual density of those, under this model, the density of those cosmological neutrinos is something like in approximate and broad figures, 10 to the 10th per cubic meter, or that sort of thing. So there's huge numbers of them. They are everywhere. In fact, I have shown that they do have an effect on space, but that effect is spread over hundreds of thousands, or more likely hundreds of millions of light years, or tens of millions of light years. That effect is spread over. Its local effect is almost non-detectable. It's not detectable. But space is, I've seen some people have come up with ideas that space is very dense and all sorts of things can happen. But that's a mathematical solution. Space is space. The only way space can expand is if the electric permittivity and magnetic permeability vary. That's the only property it has for space to expand. And I've got no indication one way or the other where that is occurring, but I think it isn't. I can explain everything, including photon redshift from distant galaxies, without the need for an expanding universe, and without the need, and under terms that satisfies the Tolman test. That's not a great deal of difficulty.
We should have a mini conference on that topic as well. I think that's very interesting.
So
yeah. I think we should also have a mini conference on that topic as well some other time. That would be great. Yeah.
Well, I will be giving some further talks to Quicycle at some time in the future. But I don't have any great difficulty. I could, maybe we could combine Quicycle and particle physics. Yes, but in the end, when you understand the physical origins of gravity, you will answer a large number of questions. And when I talk about the physical origin, I mean, you may have seen there on my third slide, or whichever one it was, the different fields. Newtonian, 1 over r squared, Einstein, 1 over 1 plus alpha over r times r squared, and 1 over r squared e to the alpha over r. The dominant part of the theory is Newton's 1 over r squared. And it applies in most cases. I think Einstein was probably a little brash to suggest that Newton's Newton's theory was a first approximation to his. Okay, yes, it is, but Einstein's mass distorting space-time, he didn't explain what space-time was, nor did any of the people who read it, but it should be rather obvious that space-time distortion is redshift. When redshift occurs, distances become longer, times change. That's space-time distortion is redshift, but he didn't mention that. No, I've got no idea why, because he used it. Redshift is alpha over 2r.
Hey, Vivian, this is Chandra.
Yes, Chandra.
Basically concur with your assessment about the space property, dielectric constant, and the magnetic permeability. They are of profound importance, and they are physical properties of the space as Maxwell's equation, as validated by 1876, I think. And we are neglecting them and folding them into C or C square, calling that as a fundamental constant. C is never a fundamental constant. It's a secondary parameter derived from epsilon naught mu naught, or in a material medium epsilon and mu. Because C is a derived parameter.
Well, to me, the fundamental concepts, the only ones I use are charge E, speed of light C, which means epsilon naught and nu naught.
They are more fundamental to me.
H bar or H, they are measured. I mean, many people have many different theories. I think the objective as a theory is not to produce beautiful mathematics like the standard model does. The objective of a theory should be to match experimental observation and, if possible, make predictions that can be tested. Now, just that what I've done, I've matched a lot of experimental observations. I've explained some, like the skin effect, that had no previous explanation. And I have made in all of this work predictions that can be tested. Now, if a theory has been forwarded and other things are fundamental or something like that, it's the use of that is in its ability to match observation. And I regard that as the test, not how good somebody's mathematics has been.
Yeah, those are positive things. Thanks.
Do you maybe have some intuition why there is different sign between for Coulomb repulsion of the same signs, while for Newton we have attraction? Do you have some intuition? Because this is very difficult. We are trying to understand it with Manfred.
Because of the differential properties of space and differential. All photons have mass. Has anybody read Einstein's 1911 paper on when he calculated the redshift from the sun? And he did that just by calculating the effect of Newtonian gravity on photons with mass. If you read that, you'll find that he attempts to describe the bending of the light rays around the sun as being due to a change in the refractive index. Yes, well, his guess was quite good. There is a change in the refractive index of space, and it doesn't matter whether the mass is, whether it's a particle or an antiparticle or a photon, the response will always be the same. So there's no such, well, according to this, there is no such thing as anti-gravity. And besides, anti-gravity is not going to do you any good traveling through space because there's no gravity to travel against. Sorry about that. Might be good for I suppose the best anti-gravity they've got so far is these things called rockets. They're pretty good.
Yeah, and Jarek is asking why there is in electromagnetism repulsion and attraction.
I guess, I think with electricity, I would respectfully suggest that it has been answered by QED theory. So that takes care of electricity. My understanding, and I've tried to have a look at it with magnetism, I haven't spent too much time on it. But I gather by you asking that question, nobody else has written the answer either, other than that when you get two magnets together and you point the poles together, the opposing poles, they attract. That's all I can say. So yes. I'd say when it comes to charge, QED handles it. When it comes to
I guess the problem I see there's no real physical explanation. At least that's what drives me. I want to understand why these magnets push each other away, because exactly how, right? So we are all trying to find a model that would explain this from like first principles or something. You know, like Robert Close model, that's the one I understand the best. Like in his model, right? For instance, space is an elastic solid and everything is waves, just like in your model where you have, you know, an electron is composed of actually photons going twice around in his model as well, and it's all based on elastic waves in elastic solids. So this model, for instance, can explain gravity, but there I don't see exactly what charges. I don't understand it yet. So, you know, it must be some effect based on wave interference or something, but like I just want to know why. Like why is there plus and minus charge exactly, like physically? You know, that at least what I would like to find out. So
Well, just very briefly on that, physically, the difference between positive and negative charge is because there are positive and negative electric fields. And the fields are caused, they're part of the photons, they're conserved. You have a positive in one direction means a negative in the other direction for conservation purposes. So the fields, do you accept that, first of all, that positive and positive and negative electric fields can exist and do exist?
oh, totally. But just like I don't see like why. I want to know why. I don't think
Why
anyone can answer that yet. That's why we're all here. Like fundamentally, why? You know. Anyway, that's probably. I don't think anyone can answer that. It's just, at least in my head, I always ask that question.
Do you know the Sine-Gordon model?
Yeah, of course, exactly. Yeah. We talked about this, so that's exactly. This would be an explanation, and that's why I like your model.
You have
at least that part.
Screws.
Exactly. Yes, Sine-Gordon. Totally agree.
You have
That would
right
be an
screws
explanation.
and left
Yes.
screws, and right and
Yes,
right.
totally.
Parallel,
Exactly.
and right
Yes.
and left attract each other.
Totally. That would be an explanation. That's what I mean. Yes, that's an explanation.
Yeah.
But it doesn't explain everything yet, right? It explains some parts, and then it doesn't explain some of the things.
I can offer a little bit of a statement about mass. You know, why do things have mass? And it's if we summed up that the photons don't travel through space infinitely fast. Space offers some resistance to them through epsilon naught and mu naught. The resist now, a property of mass is its ability to resist inertia. Well, space is doing the reverse. Space is resisting inertia, and in doing so is imparting mass to the particles that are moving through it. So that will take care of mass. And you'll find...
Repeat? I didn't, it was too fast. Could you repeat?
There are many masses. There are 4 masses at least, types of mass.
Well, yeah, I also think the comments, there's a difference between rest mass, right, and the mass you derive from the energy. And I think there's some conflict of the we also use the same word, but you mean different things, really, right?
As 4 masses, I mean there is mass as energy releasing annihilation. There is mass as inertial energy. So these 2 are equivalent from special relativity. But we have also the other 2, mass in gravity, which is we don't know. We know for bulk matter, but for electrons we don't know. Experimentally, there was 1967 this Fairbairn-Wittenbaum. We don't know for electrons. For antimatter, there are hypotheses in both sides. If they are attract or repelled, we don't know. For gravitational mass, and there is 4th. There is this the Broglie mass for the clock, for the Zilberberg clock. We know for electron there are experimental confirmation. For the others we don't know. There is just hypothesis. That's all.
Viv, could I suggest that you take us through your explanation of the radial differential of epsilon mu as a result of the nucleon rotations generating the gravitational effect?
Yeah, okay. Well, first of all, just before I do that, I know that several different masses have been proposed, but I've never seen anything to suggest that those masses are other than the same. And under this model, they will all be the gravitational mass, rest mass, inertial mass. I haven't seen anything that suggests you add energy to an accelerated particle. To accelerate it, you add energy, and that energy is absorbed by, just taken up as increased mass due to the relativistic corrections. Anyway, what Arnie is saying, okay, I'll tell you this: the actual origins of gravity. Protons and neutrons have very high frequency, and as Feynman pointed out, high frequency changes the electric permittivity of space. Now, if you have enough nucleons with a very high frequency, it doesn't take terribly many nucleons before you reach the Planck frequency, which is the inverse of Planck's time, which is the highest frequency possible. So when you have a huge number of oscillating electric fields associated with nucleons, their number builds up, and the number required to get to Planck's frequency is way under 1 gram. Then all that's happening is that the photons in a mass are just distorting the electromagnetic field around them by changing the electric permittivity by their huge amount of Planck's frequency generated by the nucleons being out of, they're not synced. Planck's frequency is about 10 to the 44 hertz. Nucleons are about 10 to the 23 hertz. So by the time you have about 10 to the 21 nucleons, which is, I think, under 1 gram or something like that, you're reaching the Planck frequency. And it just takes a huge number of these Planck frequency oscillations to start distorting the electric permittivity of space. The differential of the electric permittivity of space gives Newton's inverse square law as the first approximation, the Einstein's approximation as the second approximation, and the exact solution predicts the existence of those structures seen at the center of galaxies. So when Einstein in 1911 wrote his refractive index depends upon electric permittivity, when he was talking about electric permittivity, well, that's basically the origins of gravity. Linear photons respond just the same as rotating photons because they're frequent. In all cases, the frequency, the Planck's frequency at about 10 to the 44 hertz is so much higher than the other frequencies, photons or whatever they are, and nucleons are about 10 to the 23. The difference is so much that they all respond the same. And it doesn't matter whether you've got a proton or a positron or an electron or whatever, they're all photons, they'll all respond the same to gravity. And of course, as you can see from that, that leaves absolutely no space. It matches everything that Einstein's done. It matches everything that Newton's done. It matches everything that's been observed. That's gravity.
So are you saying it's essentially a refraction towards the increase in electric permittivity?
Yeah, the speed of light is determined by the electric permittivity, but the diffraction is determined by the bending of light is determined by the differential of the electric permittivity, and it's that differential that gives rise to gravity, and that's why it requires such a. It's still an electromagnetic effect, but that's why it requires such a huge force. That's a huge mass to get some distortion. And that also gives, because massive mutual attraction, M1, M2, mutual attraction, well, the refractive index change introduced by one party will attract another and vice versa. It's got all of the properties of gravity. And it doesn't rely on anything else, and it's weaker than inverse square too, which and it matches. I haven't come across anything yet that it doesn't match.
So do you think it goes all the way to basic infinity, or do you think there is, some limit?
It just peters out eventually. I mean, eventually you get to the stage. Down here on Earth's surface, unless you've got some really, you can measure gravity, but you can't measure the differences between gravity at this height and this height unless you've got some super sensitive equipment, which I don't know about. But we can certainly look at it, and you can look at this about this height, and I can let it go, and it goes down. We know gravity works. But yes, it does extend to infinity. And just between you and me, gravity extending to infinity, when gravity is less than inverse square, is the reason why a steady state universe won't collapse. You do the calculations, you find out that when gravity is weaker than inverse square, you just do the calculations, you find out that gravity tends to zero at infinity. and it gets to practical zero under quantum terms well before that. So that's why I suggested earlier, I think the cosmologists have been headed in the wrong direction for a long time. And the best example of this is every time they've got an improved telescope, they say, wow, we've now got these fully grown galaxies, huge
I
galaxies.
know, exactly, right? Yeah, I totally read all this stuff as well. Yeah.
Huge galaxies
Mm.
that were first explained as being 2 billion years after the Big Bang. And then along comes Hubble, and they explained 1 billion or 100 million or something. And now what are they talking about? I don't know. It just happened instantly with the Big Bang. Forget it. They are just wrong. And well, I've been in, as mentioned earlier, I've been in business for a long time. One of the things I found out in business is that if you're wrong, if there's something wrong in your organization, you better be the first to know. Unfortunately, when it comes to cosmologists who think that they are world's best gift ever granted in terms of their intellectual capability, they don't want to be the first to know. Neither do they want to be the last to know. They don't want to know. You try telling somebody like Graham Greene that he's doing a world tour at the moment. You try telling him there was no Big Bang. They don't want to know. They've got this wonderful mathematics that they think nobody can understand. And my apologies to any mathematicians, but anyone who is any good at mathematics and physics would have at some time looked at Einstein's Foundations paper to see if they could understand it. Well, nobody did. Well, present case included. And they don't want to know. And all I'm suggesting, yes, okay, there are some things I didn't handle. I mean, the origins of positive and negative charge attraction. Yes, that's handled by QED theory. No, I'm really not interested in finding out what causes magnetism. I'm quite happy with the fact that you get two magnets in the right poles. I've worked on it a bit. If somebody was interested in cooperating, yeah, maybe we can do something, but I have no great interest. It works.
So regarding magnetism, if you have Coulomb interaction and Lorentz invariance, then like in Feynman famous lectures, you get magnetism automatically from Coulomb plus Lorentz invariance.
Well, okay, if you've got an explanation, that's fine. I had no.
So you need the Coulomb, but I haven't seen that the Coulomb in your derivation.
Well, yeah. No, it's one of the things I have no interest in working out. I think having gone all the way, starting from nucleons and building everything up and building up to gravity, and it's all under the one banner, all under the one model. QED has done a good job with charge. I'm quite prepared to accept that, even though I don't possess to be able to make QED calculations.
So,
But
Coulomb is obtained experimentally, for example, in liquid crystal experiments. So it's not a problem to get a quantized topological charge, and you look at acceleration, and it agrees with Coulomb interaction, for example, and they get this kind of experiments. So it's not that difficult.
Well, I think you're talking about your model, Jarek, right? Well, so of course everyone here has their model,
I'm
right?
talking about experiments.
Jarek is talking about magnetism.
Experiments. I'm talking about experiments on liquid crystals. They get Coulomb interaction for quantized topological charges. I put some articles in the chat. So one, you have Coulomb interaction. Second, Coulomb interaction. So it's not that difficult to get Coulomb interaction and charge quantization. You have topological charges, and they effectively, for example, you look at and it agrees with Coulomb acceleration. So they experimentally get Coulomb interaction in liquid crystals for topological defects. So I'm not talking about any specific model, but just about experiment.
Any other thing I would add about, I'd like to suggest about, there are many other models available, and this is one, but unless you model, I would suggest that some of the answers I gave for nuclear physics are just totally, I mean, nobody knows what the skin effect is, or they don't know it. It's been puzzling them for a long time. I suggest that gave the answer, the same as it gave. Nobody knows the physical origins of Einstein's relativity. I suggest that answer that gave that answer, and that the model yeah, sure, I haven't answered why magnetism is attractive and repulsive, but it just is. I haven't answered why the charge of the magnetic moment of a particle is charge times radius. It just is. But the rest of it, I think I've done a reasonably good job of going all the way through, and do respectfully suggest I know.
I completely agree, but there are these holes at the bottom, so it might be worth to try to fill them. Yes.
I've also been trying to think a lot about this. I mean, if we agree that everything is based on photons, whether they're rotating photons or linear photons, so that's electric and magnetic field 90 degrees to each other, which I think I would argue they're not really separate. They're just two manifestations from different points of view of the same underlying thing. You can't separate electromagnetism. So it's really a topological effect, in my opinion. When you create an electron, you're creating a flow that's going in one topology, and its magnetic field will therefore orient in a different, you have axial versus equatorial. So as soon as you have a rotating system, you're going to have chirality, which is going to be north from one perspective and south from the other. You can't have do we have magnetism in the absence of electrons? So, it's like chicken and egg situation, but they're intimately related to one another. They're just opposite sides of the same coin. So I don't know if that makes sense.
I would suggest for experimentalists that perhaps you could try to bend a photon around its electric field, and then you can get a magnetic monopole.
Yeah. John talks about that it would decay instantly into an electric monopole because a magnetic monopole would require too much mass.
Yeah,
it cannot.
My own impression is it would be, I won't say impossible, but next to be exceeding impossible to get them to bend around their electric field and the magnetic field. But that's nothing to stop people trying. But that's the only, if you're looking for a magnetic monopole, I think that's the only chance you've got of getting one.
Any more questions? It's really late for you, so for you it's like probably 3 o'clock in the morning. So
you're happy, Chantal, are you happy with that explanation for quarks?
Oh, I thought that was great. No, I really like that part. I think that's really awesome.
That particular part of it, there's a couple of episodes on YouTube. Go to Quicycle.com and search for me, and you'll find nuclear binding and nuclear structures, which go into, both of which go into what I've introduced you to in much greater detail. And
can we put this video also on YouTube? Is it okay?
Well, yeah, as far as I know, it's going on YouTube.
A last question, if I may ask, spin for you is the same as a classical, orbital momentum. Spin doesn't have, you don't treat it differently than any other angular momentum.
Spin in all cases, what quantum mechanics guys call spin is just angular momentum I omega, which mr squared, and times c over r. And as I said, that's why the very, very small mass of a neutrino is why a neutrino can still carry away the same spin as a proton, which is what, 10 to the 20 times more massive, or 10 to the minus 10 times, 10 to the 15th or 14th times per massive. It can have the same spin because it's 10 to the 14th times less diameter. But spin at all stages, spin is angular momentum, as was originally forwarded by coolant by the Germans when they did it.
Uhlenbeck and Gaudsmit.
Uhlenbeck and Gaudsmit. Yes, thank you for that. Sorry about that.
Not only angular momentum, but also magnetic dipole moment of spin. It is also crucial for spin.
Yeah, I think what I was going to say is that very early on, after electrons were discovered, their wave properties were known. Now, when you have people like Dirac and Schrödinger, they know nothing about an electron. They really had no option but to try and treat it as a wave. And they did a good job and extended it okay. But the problem is quantum mechanics has gone from the limit of the smallest size particle that you can have, which is quantized, to saying that everything which is quantized is a wave. And then they're treating everything as a wave. And that's sort of wave. The waves have fields. Field theory originated. The mathematics is very, very complex. But they persisted with it in the absence of anything else. I respectfully suggest that something like this model has shown has been rather useful, particularly in nuclear physics, but in other areas as well. And that people would, using this model, as I said, the model is one where a field generates the particle and then the particles generate the fields. But so to some extent, could be considered a unified field theory, because I said we start out with particles, start out with fields, generate particles, then use those particles to explain all the other fields, including gravity. But I think it's better that just you have particles, treat them as particles, and I think it'll get further. Really, I think the standard model just leaves so much to be desired. It explains so little, and every time they get a bigger toy to play with, except for the, or even the James Webb Telescope is now presenting with problems that they can't say. How do you get a fully grown galaxy the size of Andromeda or our galaxy couple 100 million years after the Big Bang? I'm sure some mathematician will come up with some way. But isn't it just simpler? Look, the gravity is weaker than the inverse square. That's proven by the way Mercury orbits the sun. So gravity is weaker than inverse square for all suns. Therefore, it's inverse square. An infinite universe is stable. I mean, when Einstein found the redshift and attributed it to, and it was attributed to an expanding galaxy. Now, if you read Einstein's paper, he only considered a finite universe. Just between you and me, it doesn't matter what form of gravity you have. A finite universe, even if gravity is weaker than inverse square, a finite universe will still collapse. It is only an infinite universe that won't collapse. Man, the infinite universe, you can build a telescope 10 times more powerful than the James Webb Telescope, if you want to. If it is physically possible, all they're going to do is seeing the same thing in greater detail.
I agree, because, you know, one rotation of the Milky Way is about 200 million years. So if you want to have a mathematical model of building a galaxy, it takes many rotations, right, to build a galaxy. So it takes billions, or at least more than 1 billion years. And that's the problem. Yeah, I see as well. Yeah.
Yeah. And the worst thing, and I'd love to get somebody who believed in the Big Bang and say, okay, well, guess what your maths indicated? You got a 1 in 10 to the 60 chances. So how do we double or nothing, $10 at a time, and winner, you can either quit, or if you get to 10 to the 60 and you correctly picked it every time, you'll be a very rich man. But frankly, I think you'll be broke by $50. You'll lose $50. You won't even get that far before you get it wrong. Maybe $100 or something like that. But those odds are zero. And they don't seem to, mathematicians don't seem to realize that. They don't want to look for something else. The observed redshift, which they said is predicted, is an indication of the expanding universe, is exactly what you'd expect in an infinite static universe. Exactly.
So how does light lose energy in your model? Like, do you have a model for how light loses energy over the distance?
Well, it's the same way that particles lose energy. I mean, you know, almost all the cosmic rays we have in our galaxy come from within the galaxy. To put it, the easiest way of wording it is, if you've ever had a look at, you've seen pictures, or you've obviously seen pictures of galaxies and the spiral arms are going around. Yes, you've all seen spiral arms on galaxies, and the spiral arms lag the rotation of the galaxy. It was only on one or two we could explain something, but they all do that for the simple reason that there is a universal drag factor throughout the whole universe, otherwise known as cosmological neutrinos. They exist in huge numbers. They have the property that they slow down things. They create what you'd call a viscosity. They have a property that they slow down things according to their momentum. And as a for instance, we all know that Mercury should orbit the sun, losing 43 or with a 43 arc seconds difference between Newton's prediction and Einstein's general relativity. And I get the same prediction in my calculations in that paper I referred to at the beginning. But Mercury's actual orbit has been measured at about 41.8 arc seconds per century. Something is slowing it down. And the only thing that can do that, which it actually does, is there is a universal drag that slows the photons down according to their momentum, and it slows every particle down according to the momentum of the individual particle. So it slows cosmic rays down and traveling in interstellar space, and very few make it more than 2 or 3 galaxies distance, and that's been known for a long time, but it's attributed to slowing down by the cosmic background radiation, but that's very, very slight compared to the number of cosmological neutrinos. And that same calculation shows that for a single nucleon orbiting at Mercury's distance, it will be slowed down by about what the difference between what Einstein and I predict and what is observed. So there is this universal thing that is slowing everything down, including photons, and that's all the redshift is. And that's what Hubble at the end of it, towards the end of his career, believed it was something like that. That particular effect, it also satisfies the Tolman test, or in Tolman's mathematics, he was a bit ambitious, I think, and he tried to find every possible excuse that he could get. But it wasn't very good, and this effect gives the same Tolman test answer as does the expanding universe theory. So, what more can I say? Anyway, if you're really interested, have a look at that. Go to the website.
I'll take a look. I'll take a look.
Take a look at
Okay.
it. Everything is in the book. It took me a long time to do. That's why I've got a few grey hairs. But I did try initially to publish it. Same early in my career, I tried to publish stuff that wasn't standard model, and I just got ridiculed from one end of the globe to the other. And learned from that, don't bother arguing with referees, a lot of whom they don't know anything than their own speciality, and they're not going to let anything be published that differs from what they think. And I just said, just get on with it. And I did that in my career, and then I finished up taking a commercial product out on the field, much to the annoyance of all the academics who said I was wrong and would never work. I made quite a successful living. In fact, successful enough to finance all of this own study myself, and I just learned out of it. Don't bother arguing with referees. They're going to find some excuse. I'll admit that I thought I was fortunate at the Institute of Physics. One of their journals did accept it. And yeah, I had nothing against them. That's the way it goes. I mean, one American publication, I won't mention, I wrote to it, and it was a similar paper to what the Institute of Physics said, and they came back with, the editor came back, oh, the mathematics isn't complex enough for our journal. I think that sums up physics at the moment. Fundamental physics has just been totally hijacked by mathematicians. They think that nobody else can understand them, which would be fine if they could understand maths themselves. But they've all, I mean, ALL, capitals, because nobody who's a physicist would not, who wanted to be a good mathematical physicist, nobody would not look at Einstein's field equations in his paper, try and work that out. They've all done it, they've all goofed it. And if those who disagree are quite welcome to write a letter of refute to the Institute of Physics, and I'll publish it, and I'll take great delight in pointing out why they're wrong. I'll be polite, of course. There's, as I said, I've gone all the way through, started at the smallest subatomic particles with this model and gone all the way through to what the hell is gravity. If those who have, yeah, you're entitled to have another theory, and you can regard my theory as an opinion, but if you do have another theory, at least make sure it does cover more than just one or two things, you know, like structure of a, it's so long since I've looked at some of the bosons, like the Higgs, the W or Z bosons, which last for about 10 to the minus 20 seconds or something like that. And somehow out of that, they've got to generate things in real life that have lasted for billions of years. Like, get real, it's just not going to happen. Anyway, I think that's about it, unless somebody has some more questions.
Yeah, I think it's getting really late, so thank you very much. Unless anyone has any questions.
Okay, well, thanks for attending my talk, folks. And thanks for the invitation.
For great talk. Thank you.
Thank you.
Cheers.
Bye.
Bye.
Thank you very much.
Bye. Thanks.